Hello everyone. Now as we know that a wave is created or a wave is generated whenever a medium is disturbed. But what if the disturbance created is very huge or is of large amplitude? Now whenever a disturbance of large amplitude is created in a medium, what happens is that there is sudden increase in various parameters or there is sudden changes in various parameters. Now, whenever a large amount of energy is released in a very short area and very short time, what happens is that there is large increase in temperature, pressure as well as density of the corresponding medium. Now, for example, let us say that in the case of the bomb explosion, whenever a bomb explodes, what happens is that there is a huge amount of energy is released in a very small space. Because of that huge amount of energy which is released in a very small space, what happens is that there is sudden increase in or sudden changes in especially increase in temperature as well as pressure as well as the density in that corresponding space or in that confined space. Now, whenever there is sudden increase in temperature, pressure as well as density of that corresponding medium, what happens is that because of these sudden changes in these three parameters, that is temperature, pressure as well as the density, mechanical wave is created which carries a very huge amount of energy. Such a kind of wave where that mechanical wave carries a very large amount of energy which is created by a sudden change in pressure, temperature as well as the density of that corresponding medium. For example, gas medium, we call it as shock wave. So, basically shock wave can be defined as it is a narrow surface that manifests as a discontinuity in a medium through which it propagates at supersonic speeds. It is characterized by sudden changes pressure, temperature and density of gas through which it propagates. So, each and every shock wave is characterized by sudden changes or sudden increase, we can specifically say, in pressure, temperature and density of the gas through which it propagates. So, we can say a shock wave is a mechanical wave created by sudden dissipation of mechanical energy in a small space. There is one such parameter which characterizes the shock wave, which is called as Mach number. Okay. The Mach number is denoted by capital M, and it is defined as the ratio of speed of the object to the speed of the sound in the medium. So we can write Mach number as is equal to object speed divided by speed of sound, the medium. Capital M is the Mach number, then it is U by A, where U is object speed and A is speed of sound. If we consider the medium to be air, then the speed of the sound A is given by square root of gamma r t, where gamma is ratio of specific heat of gases and R is a gas constant and T is temperature. I repeat, we can define the Mach number as the ratio of the speed of the object to the speed of the sound in the medium, which is given by Mach number is equal to U by A, where U is the object speed and A is the speed of sound in the medium. If I consider the medium to be air medium, then the speed of the sound in the air is given by A is equal to square root of gamma r t, where gamma is the ratio of specific heat of the gas mixtures, R is the gas constant of those gas mixtures and T is the temperature. Now, whenever shock wave is created, these shock waves have certain properties. So, let us see what are the properties of shock wave. The first property of a shock wave is shock wave have Mach number always greater than 1, means that the speed of the shock wave is always greater than the speed of the sound in that corresponding medium. Okay. So, first one, shock waves have Mach number greater than. Second one is shock waves, they obey the law of fluid dynamics. Third one is whenever a shock wave is created, that results in the change in the entropy of that medium. Fourth one is shock wave exists in a medium of propagation confinement very close to a thickness of about 1 micrometer, in which there is a large magnitude of increase in pressure, temperature as well as the density. Shock waves exist in a medium of propagation confined to a small thickness of 1 micrometer, in which there is large change in pressure, temperature and density. And the shock wave the supersonic flow is deaccelerated into subsonic flow here. The changes are adiabatic process. So, whenever a shock wave passes through a medium, the supersonic flow usually deaccelerates into subsonic flow, in which the changes are related, resulting in the adiabatic process. So, these are the 5 important properties of the shock wave. First, shock wave always have Mach number greater than 1. They obey the law of fluid dynamics, and shock waves created results in change in entropy. So, it exists in a medium of propagation confined to a very small space of thickness of about 1 micrometer, in which there is large increase in pressure, temperature and density of that medium. And whenever a shock wave is deaccelerated, the supersonic flow deaccelerates into subsonic flow, and the process is adiabatic change. So, these are the important properties of the shock wave. Based on the variation of Mach number, certain mechanical waves has been classified into 5 types. They are: first one is acoustic waves, second one is ultrasonic waves, third one is subsonic waves, fourth one is supersonic waves, fifth one is hypersonic waves. Now, apart from these 5 kinds of classification, there is another classification which gives us a transition from the subsonic to supersonic, which is called as transonic waves. Now, these waves are classified based on the variation of Mach number. Now, let us start in detail one by one. What are its properties and how they behave? Now, let us start with the acoustic waves. Acoustic waves are nothing but normal sound waves which have speed equal to the speed of the sound in air. So, it has speed equal to 333 meter per second in air. And if you consider the frequency of the acoustic waves, the frequency of the acoustic waves is also similar to the frequency of the sound, that it ranges from 20 hertz to 20,000 hertz. And the amplitude of acoustic waves is also small, similar to the amplitude of the sound waves. So, amplitude is small. Now, these are the properties of any acoustic waves. When it comes to the Mach number of acoustic waves is always less than 1. Second one is ultrasonic waves. Now, in the case of ultrasonic waves, the major variation or the major difference is regarding the frequency. In the case of ultrasonic waves, the frequency of the ultrasonic waves is more than 20,000 hertz, or we can say the frequency range is beyond 20,000 hertz. And apart from this, it is similar to the acoustic waves. The ultrasonic waves also has the speed of 332.3 or 333 meter per second, and the amplitude of acoustic waves and amplitude of ultrasonic waves both are similar. The frequency is the only major change here, where the frequency it is beyond the 20,000 hertz, where the ultrasonic waves can be majorly used in ultrasonic scanning, ultrasound scan, and in the case of sonar. Third one is subsonic waves. The subsonic wave can be defined as the speed of a mechanical wave or a body moving in a fluid medium is less than that of sound, then the waves, they are called subsonic waves. Now, in the case of subsonic waves, the speed of the subsonic wave is always less than that of sound. And if you consider the Mach number of the subsonic waves, the Mach number is always less than 1. Mach number of subsonic waves is always less than 1. And if you consider the pictorial representation of the subsonic waves, so if you have an object moving with the speed of Mach number less than 1, where the speed of the object is less than the speed of the sound in that medium, then the waves generated by such an object expand in this pictorial manner Here, if the speed of the object is less than the speed of the sound, you will be able to hear the sound waves created by the object first, and then you will be able to see the object which is moving in a corresponding path. So that's why, because of this, as you can see, the sound waves are expanding in front of the moving object first, and then it goes on expanding in the backward path of the object around it in a circular manner or a spherical manner. So this is regarding what are subsonic waves, and all the objects which are moving on the or which are moving with the speed less than the speed of the sound, they all create subsonic waves. Supersonic waves are the mechanical waves generated by an object moving in a liquid medium where the speed of the object is greater than the speed of the sound in that liquid medium or else the gas medium. Moving mechanical waves generated by an object moving in a liquid medium or air where speed of object is always greater than speed of sound. So such a kind of waves we call it as supersonic waves, and the Mach number of supersonic waves is always greater than 1. So such a kind of waves where the Mach number of is always greater than 1, they are called supersonic waves. Now if you consider the pictorial representation of supersonic waves, here in the case of supersonic waves, since the speed of the object is greater than the speed of the sound, you will be able to see the object first, and then you will be able to hear the sound generated by the object. So if the object is moving in a straight line, where the speed of the object is greater than the speed of the sound, then the sound waves are expanded in this manner where you will be able to see the object first, and the expanding sound wave will be expanding in a spherical manner behind the object. A body which is traveling at supersonic speeds, it zooms ahead, piercing its own sound curtain, leaving behind series of expanding spherical sound waves, and these sound waves are heard after the object is seen, because the speed of the object is greater than the speed of the sound. Now if you draw a tangent to these expanding sound waves, a common tangent, A cone is created which is called as Mach cone. Okay. And a common angle is created between the path of the trajectory of the movement of the object as well as the tangent drawn to the expanding sound waves. This angle we called as the Mach angle. This is represented by mu. Mach angle is the angle formed between the trajectory of the path of the moving object and then the tangent drawn to a common tangent drawn to the expanding sound wave. The angle made by the axis of the cone and the common tangent drawn to expanding sound waves Now, the Mach number is represented by mu, which is given by mu is equal to sine inverse of 1 by m, where m is nothing but Mach number. So, fifth one is hypersonic waves. Now, hypersonic waves are a special class of supersonic waves for which the Mach number is always greater than 5. So, the hypersonic waves have Mach number greater than 5, and these kinds of waves are created whenever there is an explosion of bomb or earthquake. Hypersonic waves carry a huge amount of energy, because of which hypersonic waves can be harmful or hypersonic waves can be destructive. And the last one is transonic waves. Transonic waves are class of waves which have Mach number in the range of 0.8 to 1.2. These transonic waves, they gives us the transition of the waves from the subsonic to the supersonic. As you can see, subsonic in the range of 0.8 to 1 and supersonic in the range of 1 to 1.2. So, these are the classification of mechanical waves based on the variation of Mach number and how these mechanical waves behave. So, in the next session, we will see a model which explains the shock wave, and then a device which creates a shock wave which is called as a ready shock tube, and then we will see the application of shock waves. Thank you.